Welcome everybody to Function Notation Lesson 2. Or Functions Lesson 2, sorry. Today we are looking at function notation. So up until this point, we have been dealing with equations to represent relations. So I'm going to scroll right down. We're going to skip mapping notation. We just don't have time to do it, but we are going to look at function notation, which is great. So there's a lot of stuff going on here, but the biggest thing I want to talk about is we have been looking at equations to represent relations. So a good one I've got is y is equal to 2x plus 3, and that is the example here. So that is the equation of the relation. We have our inputs here and our outputs here, and we can plot them into a XY table if we want, or an XY graph if we want. But now that we've learned about these special types of relations called functions, where every input has only one output, there's a different way we can write function notation. So we can say that, basically what it is you're replacing this y with a symbol f of x. So it is pronounced or read f of x, and that is saying that this is a function of x, and you leave the equation the same. So basically all you've done is replaced the y with this f of x is equal to 2x plus 3. And what it's saying is that this is a function where x is the input, right? This is a function of x, f of x. And these two pretty much mean the same thing, but the bottom one is stating that, yes, for sure, this is a function. It works, f of x. So a couple of things that we want to note is f of x does not mean f times x. So don't ever think it's f multiplied by x. That's not the case. It's not f multiplied by x. No. It is the function that is dependent on x, is really what it's saying. So the function dependent on x is 2x plus 3. Right? This is still represents the output. It still represents the output, and that represents the input. It's just basically a different version of y, saying that it is a function. The name of the function is f. So the name of the function is f. That's kind of it. So there's a lot of wordiness here, but we're going to some examples. So it says here, consider the function f of x is equal to x squared plus 5, and g of x is equal to 4 minus x. That's totally okay. We don't always have to use, f of x. We can say the function's name is g, and it depends on x. Or the function's name is m, and it depends on x. It doesn't matter. It's just a name, right? It's the name, the function of x, the function g of x, the function m of x. They're just equations. So the first thing we want to do is evaluate f of 3. So we know that our equation is f of x normally. So when there's a 3 in the brackets, it's basically like saying x is equal to 3. So what you can say f of 3 is equal to, and then instead of putting your equation, you're going to plug that 3 into where the x goes. So it'll be 3 squared, because x is squared, plus 5. And you can solve that. I'll just put a line there. F of 3 is equal to 3 squared is 9 plus 5. So f of 3 is 14. And what that is saying is for an input of 3, we'll have an output of 14. That's all that it's saying. For an input of 3, we'll have an output of 14. So if you were to do these on a table, instead of it being x and y, it is now going to be x and f of x. So with an input of 3, we have an output of 14. And you can do that for a bunch of different pairs if you really want to. The next one we're going to do is g of 1. So now we are going to use our function g, and it's the same idea. This is the general form is g of x. So now it's like saying x is 1 in the g function, in that function. So g of 1 is equal to 4 minus 1, or g of 1 is equal to 3. So what that is saying is for an input of 1, we get an output of 3. Let's do f of negative 2. So in this case, x is going to be negative 2. So we can say f of negative 2 is going to be, we're using the function f now, negative 2 squared plus 5. So f of negative 2 is equal to, well, negative 2 squared is negative 2 multiplied by negative 2, which is positive 4, plus 5, and f of negative 2 is 9. So our input is negative 2, and our output is 9. I'm not going to do D, I'll just skip it, but we're going to do E. E is interesting. F of 0 minus G of 0. Okay, so first let's do F of 0. So let's do it like this. F of 0, I'll do in blue, minus G of 0 in green. So F of 0, we are going to plug 0 in to this equation up here. What is that, green? Into this equation up here. So it'll be 0 squared plus 5, all subtract. Now we're going to put 0 into the next one, 4 into the g function, minus 0. And we solve that. So 4 minus 0 is just 4, that goes away. 0 squared goes away. So basically we're left with 5 minus 4, and that gives us 1. So f of 0 minus g of 0 equals 1. Not too shabby. The next thing is very similar. You can see we have f of x is equal to 5x cubed minus 2x, and then it stops. That's our whole function, and then there's a little bit on the end saying where x is going to be all real numbers. It can be any number. Determine f of negative 3. Okay, so we want to do, I gotta get out of this somehow. There we go. F, I'll just maybe scroll up because I think that's the issue. I'm writing too close to the bottom of my screen. F of negative 3 is going to be 5 multiplied by negative 3 cubed minus 2 negative 3. Anywhere we see an x, we have to put in our input. And then we can solve. Negative 3 cubed is going to be negative 3 multiplied by negative 3 multiplied by negative 3. This will be positive 9 multiplied by negative 3 will be negative 27. So I'm going to have f of negative 3 is equal to 5 multiplied by negative 27 minus 2 multiplied by negative 3 is negative 6. And then we are going to do 5 multiplied by negative 27, and that's going to be, should be, oh my gosh, hang on, sorry, negative 135, and then subtract negative 6 is like plus 6. So f of negative 3, negative 135 plus 6 is going to be negative 129. So f of negative 3 is negative 129. The value, I won't do this one, but the value of f when x is equal to 2 is the same as find f of 2. We're not going to do anything with the image of 7 under f. This is the mapping, and we're just not going to do that. So for E, we can bring our polynomials into it. It says, determine an expression for f of a. So what we want to do is we're going to put a in anywhere we see an x. So f of a is going to be 5a cubed minus 2a. That's it. That's the function where f is a, or f of a. Now we're going to do f of 2x. So now anytime we see an x value, we're going to replace it with 2x. So the function of 2x is going to equal 5 multiplied by 2x cubed minus 2 multiplied by 2x. So 2x cubed is going to be 2 cubed and x cubed. So it'll be 8x cubed minus 2 multiplied by 2x is 4x. So f of 2x now is going to be 5 multiplied by 8 is 40x cubed minus 4x. And that's the answer. This one you can try if you want. It is a trickier version of things, so we don't have to go too far into it. So now we're going to go the opposite way. We've figured out how to do things if they ask what's f of 5. But now you can see that we're given a function, f of x is equal to 10x minus 3. And the question says determine the value of x. So we're solving for x when f of x is equal to 47. That means that entire function is equal to 47. So what you can do is you can rewrite it as, well, instead of writing f of x, you're going to write 47 is equal to 10x minus 3. Because basically, like, this is saying this f of x term right here is 47. So instead of writing f of x is equal to all this stuff, you can just rewrite that as 47 is equal to all that stuff. And now what they want us to do is solve for x. So we have to do a little bit of algebra here. Need to get x by itself. So I can add 3 to both sides to get rid of that minus 3. And I'm left with 10x on this side and 50 on that side. And then I need to get x by itself. It's being multiplied by 10, so I'm going to divide by 10 both sides. That cancels. 50 divided by 10 is 5. And now we have our value of x. And you can always double check that and say, okay, well, now, this is just a check if you want to, f of 5 is equal to 10 multiplied by 5 minus 3, which is 50 minus 3, which is 47. So that's correct because they just said find f of x, or find x when f of x is 47, and we just checked that it works. Same idea, it says solve the equation f of x is equal to negative 23. So you would say, okay, instead of saying f of x is equal to 10x minus 3, you're going to replace it because you just said here f of x is equal to negative 23. So instead of writing f of x, I'm going to erase and write negative 23. And then I can solve for x just using some algebra, same process. Plus 3 to both sides, plus 3. That cancels, and I'm left with 10x on this side and negative 20 on this side. Divide by 10 to both sides, and x is negative 2. And you can double check if you want to. All right, more of the same, so I'm going to leave you here. We will get some practice on this in class, so thanks for watching. Don't forget to like and subscribe.